So it's quite clear that when Elon Musk said that Grok 3 is the world's smartest AI, he wasn't actually jumping on the hype train. Today, he unveiled Grok 3, which is by far the world's smartest AI across a range of several different benchmarks. In today's video, I'll get through all of the announcements that you need to understand for Grok 3 and show you guys why this is actually the world's smartest AI in its current form. So one of the first things most people are of course going to want to look at is the benchmarks. Now, if we look at Grok 3, the non-reasoning model, we can actually see that those benchmarks are pretty incredible across the board. We can clearly see that Grok 3 and Grok 3 Mini actually surpass recent state-of-the-art models like Gemini 2, DeepSeek version 3, Claude 3.5, Sonnet, and the recently updated GPT-4.
The model is still currently training, actually. So this is a little preview of our benchmark numbers. So we evaluated Grok 3 on 3 different categories: on general mathematical reasonings, on general knowledge about STEM and science, and then also on computer science, coding. So AIME, American Invitational Math Examination, hosted once a year. And if we evaluate the model performance, we can see that the Grok 3 across the board is in a league of its own. Even its little brother, Grok 3 Mini, is reaching the frontier across all the other competitors. So you would say, well, at this point, all these benchmarks, you're just evaluating, the memorization of the textbooks, memorization of the GitHub repos.
Another thing that I do love about the Grok 3 team is that they also managed to put their model into the chatbot arena. If you aren't familiar with the chatbot arena, it's not quite like a standardized test. It's essentially a test where you have 2 AI models that give you a response anytime you ask an AI question. Out of the 2 responses that you get, you essentially pick which one you think is better. It's a blind test, so you don't know which model is called which. You just receive a response, you click which one you think is better, and over time, they showcase which model has been receiving the most number of wins. Currently, the number 1 model in the chatbot arena is actually Grok 3. So even in blind tests where people aren't biased by the names of the model, Grok 3 is something that is clearly winning. And remember, this is just the non-reasoning model.
We actually kicked off a blind test of our Grok 3 model, codenamed Chocolate. It's pretty hot.
Yeah, hot chocolate.
Been running on this platform called Chatbot Arena for 2 weeks. I think the entire X platform at some point speculated this might be the next generation of AI coming our way. So how this Chatbot Arena works is that it strips away the entire product surface, right? It's just raw comparison of the engine of those AGIs, the language models themselves, and place the interface where the user will submit one single query, and you get to show 2 responses. You don't know which model they come from, and in the end, you make the vote. So in this blind test, Grok 3, an early version of Grok 3, already reached like 1,400. No other models has reached an ELO score, head-to-head comparison to all the other models at this score. And it's not just one single category. It's 1,400 aggregated across all the categories in chatbot capabilities, instruction following, coding. So it's number 1 across the board in this blind test.
And it's still climbing, so we actually have to keep updating it. So it's 1,400, about 1,400 and climbing.
Yeah, and in fact, we have a version of the model that we think is already much better than the one that we tested here.
Yeah.
We'll see, how far it gets, but that's the one that we're, working on, or talking about today.
Yeah. So actually, one thing, if you're using Grok 3, I think you may notice improvements almost every day because we're continuously improving the model. So literally, even within 24 hours, you'll see improvements.
So now, of course, is the juicy part. The reasoning model. These models are basically models that think for an extended period of time rather than just giving you an instantaneous response. If you aren't familiar with why these models do this, it's because it allows the models to think for a longer amount of time, giving them access to better and higher quality responses, enabling them to be more accurate and tackle more complex problems as well. This is something that we've moved to do as an industry because it's providing promising results and will likely lead us to truly smart AI. Now, when we look at Grok 3's reasoning capabilities in terms of the thinking models, those 2 also managed to surpass even the recently debuted O3 Mini that many people heralded as the smartest AI on the planet. But now, that's unfortunately number 2.
In the background, we can now actually talk about some concrete numbers. How well is Grok doing across tons of different tasks that we've tested it on. So we'll hand it over to Tony to talk about that.
Yeah, okay, so let's see how Grok does on those interesting, challenging benchmarks. So reasoning, again, refers to those models that actually thinks for quite a long time before it tries to solve a problem. So in this case, around a month ago, the Grok 3 pre-training finished. So after that, we worked very hard to put the reasoning capability into the current Grok 3 model. But again, this is very early days, so the model is still currently in training. So right now, what we're going to show to people is this beta version of the Grok 3 reasoning model. Alongside, we also are training a mini version of the reasoning model. So essentially, on this plot, you can see the Grok 3 reasoning beta and then Grok 3 mini reasoning. The Grok 3 mini reasoning is actually a model that we train for much longer time. And you can see that sometimes it actually performs slightly better compared to the Grok 3 reasoning. This also just means that there's a huge potential for the Grok 3 reasoning because it's trained for much less time. All right, so let's actually look at how it does on those 3 benchmarks. So Jimmy also introduced already. So essentially, we're looking at 3 different areas: mathematics, science, and coding. And for math, we're picking this high school competition math problem. For science, we actually pick those PhD level science questions. And for coding, it's also actually pretty challenging. It's competitive coding and also some lead code, which is some code interview problems that people usually get when they interview for companies. So on those benchmarks, you can see that the Grok 3 actually performed quite well across the board compared to other competitors. So it's pretty promising. These models are very smart.
Yeah. So Tony, what are those shaded bars?
Yeah, so I'm glad you asked this question. So for those models, because it can reason, it can think, you can also ask them to even think longer. You can spend more what we call test and compute, which means you can spend more time to reason, to think about a problem before you spit out the answer. So in this case, the shaded bar here means that we just ask the model to spend more time. It can solve the same problem many times before it tries to conclude what is the right solution. And once you give this compute or this kind of budget to the model, it turns out the model can even perform better. So this is essentially the shaded bar in those plots.
Right. So I think this is really exciting, right? Because now, instead of just doing one chain of thoughts with AI, why not do multiple all at once?
Yes.
So that's a very powerful technique that allows us to continue to scale the model capabilities after training.
So they also wanted to see if this was just a situation where, because they trained it for so long and on so much data, it was just overfitting and basically just memorizing parts of the test. They decided to test it on the newer AIME 2025, and the results were pretty surprising.
And people often ask, are we actually just overfitting to the benchmarks?
Yes.
So how about generalization?
So yes, I think, this is definitely a question that we are asking ourselves, whether we are overfitting to those current benchmarks. Luckily, we have a real test. So about 5 days ago, AIME 2025 just finished. This is where high school students compete in this particular benchmark. So we got this very fresh new competition, and then we asked our 2 models to compete on the same benchmark, the same exam. And it turns out, very interestingly, the Grok 3 reasoning, the big one, actually does better on this particular new fresh exam. This also means that the generalization capability of the big model is stronger, much stronger compared to the smaller model. If you compare to the last year's exam, actually this is the opposite. The smaller model kind of learns the previous exams better. So this actually shows some kind of true generalization from the model.
That's right. So 17 months ago, our Grok 0 and Grok 1 barely solved any high school problems.
That's right.
And now we have a kid that just already graduated. The Grok is ready to go to college. Is that right?
Yeah. I mean, it won't be long before it's simply perfect. The human exams won't be hard. They'll be too easy.
Yeah. And internally, we actually, as the Grok continue evolves, we're going to talk about what we're excited about. But very soon, there will be no more benchmark left.
Yeah.
Now, let's actually take a look at these reasoning capabilities in action to show you guys what these models can really do.
Grok, the reasoning model. So what are some use cases?
Yeah, so like Jimmy said, we've added advanced reasoning capabilities to Grok, and we've been testing them pretty heavily over the last few weeks. I wanted to give you a little bit of a taste of what it looks like when Grok is solving hard reasoning problems. So we prepared 2 little problems for you. One comes from physics, and one is actually a game that Grok is going to write for us. When it comes to the physics problem, what we want Grok to do is to plot a viable trajectory to do a transfer from Earth to Mars, and then at a later point in time, a transfer back from Mars to Earth. And that requires some physics that Grok will have to understand. So we're going to challenge Grok, come up with a viable trajectory, calculate it, and then plot it for us so we can see it. And this is totally unscripted, by the way.
That's the entirety of the prompt, which should be clarified, is that there's nothing more than that.
Yeah, exactly. This is the Grok interface, and we've typed in this text that you can see here, generate code for an animated 3D plot of a launch from Earth, landing on Mars, and then back to Earth at the next launch window. And we've now kicked off the query, and you can see Grok is thinking. So part of Grok's advanced reasoning capabilities are these thinking traces that you can see here. You can even go inside and actually read what Grok is thinking as it's going through the problem, as it's trying to solve it.
We should say, we are doing some obscuration of the thinking so that our model doesn't get totally copied instantly. So there's more to the thinking than is displayed.
All right, so this was the little physics problem we had. We've collapsed the thoughts here, so they're hidden. And then we see Grok's answer below that. So it explains, it wrote a Python script here using matplotlib, then gives us all of the code. So let's take a quick look at the code. Seems like it's doing reasonable things here, not totally off the mark. Solve Kepler says here, so maybe it's solving Kepler's law numerically. There's really only one way to find out if this thing is working. I'd say let's give it a try. Let's run the code. All right, and we can see, Grok is animating two different planets, Earth and Mars here, and then the green ball is the vehicle that's transiting, the spacecraft that's transitioning between Earth and Mars. And you could see the journey from Earth to Mars, and it looks like, indeed, the astronauts returned safely, at the right moment in time. Obviously, this was just generated on the spot, so we can't tell you if that was actually a correct solution. So we're going to take a closer look. Maybe we're going to call some colleagues from SpaceX, ask them if this is legit.
It's pretty close. There's a lot of complexities in the actual orbits that have to be taken into account, but this is pretty close to what it looks like.
Now, Grok 3's also entered its agentic era, which is something that I'm honestly not surprised by. AI agents are essentially the theme for 2025 and beyond. Essentially, they release something once again. They've called it once again deep research, or in this case, deep search.
So today we're actually introducing a new product called Deep Search. That is the first generation of our Grok agents that not just helping the engineers and researchers and scientists to do coding, but actually help everyone to answer questions that you have day to day. It's a kind of like a next generation search engine that really help you to understand the universe. So you can start asking questions like, for example, hey, when is the next Starship launch day, for example? So let's try that, let's hit the answer. On the left-hand side, we see a high-level progress bar. Essentially, the model not only just going to do one single search like the current RAG system, but actually thought very deeply about, hey, what's the user intent here? And what are the facts I should consider at the same time? And how many different websites I should actually go and read their content, right? So this can really save hundreds of hours of everyone's Google time if you want to really look into certain topics. And then on the right-hand side, you can see the bullet summaries of how the current model is doing, what websites browsing, what sources verifying, and oftentimes actually cross-validate different sources out there to make sure the answer is actually correct before it's output final answer. And we can, at the same time, fire up a few more queries. How about, Elon, you're a gamer, right? So
sure.
Yeah, so how about what are some of the best builds and most popular builds in Pathway Excel? Hardcore, right? Hardcore league.
You can technically just look at the hardcore ladder. Might be a fast way to figure it out.
Yeah, we'll see what the model does. And then we can also do, something more fun. For example, how about make a prediction about the March Madness out there?
Yeah, so this is kind of a fun one where Warren Buffett has $1 billion bet. If you can exactly match the entire winning tree of March Madness, you can win $1 billion from Warren Buffett. So it would be pretty cool if AI could help you win $1 billion from Buffett. That seems like a pretty good investment.
Let's go.
Yeah.
Another neat feature of this deep search is that you can actually look at the chain of thought of the model. So if the model doesn't respond with something that you wanted, you can actually look at how the model reasoned through its search data and see how it came to that conclusion. I think this one's really useful because they talk about having the model be as transparent as possible, and this is actually going to make it even more useful. So if you don't get the response that you want, you can actually reason, look into the model's thoughts, and figure out why.
And then in this case, you can actually scroll through, actually reading to the mind of Grok. What informations does the model actually think about are trustworthy, what are not? How does it actually cross-validate different information sources? So that makes the entire search experience and information retrieval process a lot more transparent to our users.
And this is much more powerful than any search engine out there. You can literally just tell it, only use sources from X, and it will try to respect that.
Yeah.
And so it's much more steerable, much more intelligent.
I mean, it really should save you a lot of time. So something that might take you half an hour or an hour of researching on the web or searching social media, you can just ask it to go do that and come back, and 10 minutes later, it's done an hour's worth of work for you. That's really what it comes down to.
Exactly.
And maybe better than you could have done it yourself.
Yeah. Think about you have infinite amount of interns working for you. Now you can just fire up all the tasks and come back a minute later.